we can get started. Welcome to the first ever, not just first of the year, but first ever Neuroscience and Society Career Fair. This has been a passion project of mine. My name is Francis Shen for a long time. I'm going to say just a couple of words at the outset and then hand it over and introduce our special guest presenters for the night. So my name is Francis Shen. I'm a professor at Harvard Medical School Center for Bioethics and Harvard Law School and MGH Department of Psychiatry. I study the intersection of neuroscience and society with a special emphasis on neuroscience and law and neuroethics. But today I'm serving as your guide through the world of NeuroX careers, neuroscience, and fill in the blank with all sorts of things. Tonight's sections are on neuromarketing, neurobusiness, neuroeconomics, neurodesign, neuroarchitecture, neuroaesthetics, and neuromusic. We couldn't fit that many panelists onto a single panel. So each night what we've done is we've got some panelists, we've got breakout rooms that start at the top of the hour, and I think we'll have a great time. So let me go over just a few bits of housekeeping. First of all, thank yous are in order, massive thank yous in order for to the Dana Foundation for funding this work, to the Harvard Medical School Center for Bioethics for supporting us and hosting the grant, to you for being here, and especially to our team of RAs. A lot of you are students, and you should know that behind the scenes of this event are a lot of other students. It was all me and a group of students. So I really want to thank you. And finally, to our co-sponsor, Simply Neuroscience. I see that Chinmay is here, and she'll be in the breakout session as well. Thanks to all of you for co-sponsoring. Thanks to all our partners on the front of the website. Couldn't do it without you. All right, so here's how the evening will work. 5 things to know. First of all, you can use the Q&A feature. So that Q&A down there in Zoom, use it, ask your questions. There'll be some time for Q&A at the end of this first hour. Second thing to know, there are breakout sessions that will happen a little more informal at the top of the hour. So that's 7 o'clock Central, 5 o'clock Pacific, would that be 8 o'clock Eastern. You cannot use the chat. So the chat is disabled. You cannot unmute unless you ask to be unmuted. So you can use your raise hand function. So after everyone's presented, I'll invite those who want to vocalize a question to raise your hand. The other thing to know, you can check out our website, neuroxcareers.org, for much more, where you can subscribe to our newsletter. And finally, you can come back again. If you like what you see tonight, you can come back Tuesday and Wednesday and Thursday. And we haven't figured out exactly what it is, but we're keeping the Zoom registration link. And much like frequent flyer program, anyone who shows up all 4 times, we're going to do something for you. It's got to be small because you're all over the world. But get those frequent flyer career network miles and it'll pay off. Okay, enough about me, enough about the evening. If you have questions, you can put in the Q&A. And with that, I'm going to turn it over to our presenters. Here is the order that we're going to do. I'll introduce all, I guess I'll introduce them as we go. We're going to start by hearing about neuromusic. We'll then hear about neuroarchitecture, neurodesign. We'll move into neuroeconomics and then into neuromarketing. And our four panelists are Dr. Uma Karmakar, our neuromarketing, neuroeconomics, Dr. Margaret Tarampi, neuroarchitecture, Dr. Jessica Gran, I think I got it right, on, not an, neuromusic, and Dr. Reed Montague on neuroeconomics. A really special thanks to all 4 of them. You should know, people in the audience, that we are paying our presenters a grand total of $0. This is on their volunteer time, and because they believe in their fields and believe in you, who are the future of these fields. So we will start with neuromusic and Dr. Jennifer Gran. She is a cognitive neuroscientist who studies music. She's a professor in brain and mind and the Department of Psychology at Western University in London, Ontario, where she runs the Music and Neuroscience Lab. She has a really cool website, which I'll put in the Q&A so you can all see it. And I believe that you'll have to confirm that you're also a professional musician as well, if I understood that right. So maybe we'll see one of your gigs too. But thank you, welcome, and we'll turn it over to you for about 10 minutes or so, and we will all learn about neuromusic. Thank you.
Yes, thank you for having me. So neuroscience of music. How does one get into this field? What is the point of this field? There are lots of questions. So I'll start there. Sort of two ways that people approach neuroscience of music. One is using music as a tool to study how the brain works. So the fact that music involves most of our sensory systems and tight interactions between our sensory and our motor systems means that it's a great tool for looking at how the brain develops some of these auditory abilities. You have to decode visual symbols if you read music and translate those to different kinds of movement. If you take lessons or if you're trying to play by ear, you need to learn how to attend to the particular part that you're interested in, or remember what it was your teacher just said to you to pay attention to, while also producing this music and trying to incorporate that new thing that you're going to try to do. Memory is hugely involved. So music, like smell, is one of the few types of triggers that pulls back richer memories. So often when we have smell, for example, it might transport us to a certain time in our life in a certain place and really brings back much more vivid and detailed information than some other types of cues. And music is one of the few other triggers that does that. So for example, when I'm trying to sell why study music to people who study more basic functions of the brain, this is the sort of messaging I would give them, that music is an amazing tool to study many different functions and how they interact. Emotional aspects of what we do. Reward. Why do we pay hundreds of dollars for tickets to music concerts when the sound is going to be way worse than whatever we could listen to in our own earbuds? There must be something we're really getting from this experience. The social aspect of it is probably part of that. So again, music and sharing and cultural communication. There's all kinds of things that we can look at. Plasticity, that's a really catchy one. People like to talk about, how could I change the brain? Is music a free lunch? I listen to music or play music. How is my brain better? And the cool thing is, normally if we want to study brain plasticity, we have to ask people to do something over and over and over again and measure their brain before and after we have asked them to do that thing, so we can understand how the neural pathways change. But musicians decided to do this all on their own, or maybe with a little encouragement from their parents, so they can provide a model of how neuroplasticity might work. So this is one aspect of why people get into music neuroscience, is it's a really rich, culturally, socially, personally relevant stimulus compared to flashing lights or beeps and boops or pictures on a screen, to study how our brains actually work. The other aspect is probably more how I got into it, which is, why do we do music? How do we do music? Music and musical behavior emerge before we are able, as babies, to speak, to move under our own control very well, to communicate our complex thoughts. We see responses to music developing, maybe even prenatally, but certainly as soon as people are born. So what's the point of music? The other aspect is that we want to know, how is it that people appropriate or understand the cultural rules of their own music. So you learn these things without even knowing you're learning them. And then you might hear music from another culture and find that the rules are different, and you don't have the same understanding or ability to process what's relevant in that musical culture compared to your own. For my own story, I really got interested in rhythm and timing. So I'm very interested in the fact that when we're hearing sequences of sounds, if I give you da 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 da, people very quickly can find this underlying beat. Da 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 da. We do it spontaneously, automatically. In fact, we can't not do it. If I give you something irregular, you're looking for that regularity much of the time. The funny thing that happens when we find that is that we start to move to it. We don't move very much to other sounds in our environment. If the truck is backing up outside my office window and I hear beep, 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 I don't find myself compelled to nod or tap along. So I was really interested in how it is that we are able to find this beat. Is it something we learn? Is it something innate? Is it a feature of the fundamental timing systems of the brain that we look for regularity? Because when we can find regularity, things are easier to understand. When we know the rules of how things are organized, we can process them more efficiently. Or is it just entirely acquired because we hear things with rhythms all the time? And this led me down, a decades-long exploration into the links between sound systems and movement systems in the brain, understanding how timing works. How is it that we're able to estimate when your toast is going to pop up, or whether when I'm clapping along to music or tapping along to music, I do so accurately or not. Why are some people so good at it and some people so bad at it, yet they seem unimpaired in other aspects of their life? So these are the sorts of questions that really led me to this field. Now, I do have a music background. I have a bachelor's undergraduate in piano performance, as well as a bachelor's in neuroscience. I had no intention of combining these fields. Just couldn't really choose when I was going to my undergrad. So I found a place that would let me not choose. At the end of 4 years, I realized no way I was going to be a professional pianist. I'm not a good sight reader, which is what you need for accompanying or teaching or doing some of the career paths. And I am not dedicated enough to sit in a practice room by myself for 8 hours a day. I just couldn't do it. But what I found early in graduate school was that all of the questions I was interested in were really influenced by my experience as a musician. So, how is it that we learn very complex sequences? And I would think about the tricks that I would use as a pianist. Can we get memory consolidation if we practice right before bed? Next morning, am I going to find myself with some savings so I don't have to work quite as hard? So, a lot of the things I was interested in, I found myself influenced by my experiences as a musician. I don't think you need a strong musical background. There are so many angles of music and neuroscience that don't require you to understand the fine details of music and how it works. People often think if they're self-taught or can't read music, they have nothing to contribute, and that's not true. Most of our musical understanding we acquire without even trying, and a lot of the testing that we do is about how people hear music. So although I have that background, it's not required to do what I do. I run a research lab. I do lots of brain imaging. I do lots of brain stimulation. So if I maybe heighten the excitability of certain brain areas, do I see that that enhances your ability to do a particular musical task? That gives me a causal way, not just a correlational way, of inferring that that brain area is actually doing something important for that behavior. And that's the sort of thing that it's hard to do in humans because we can't do very many causal interferences to people's brains. They don't like that very much when we go in and start poking electrodes in unnecessarily or taking bits out. So that's I'm very hard in the neuroscience part of it, but I have colleagues who are in music departments, music composition, music theory, who still do experimental work. I have people who are in psychology, computational neuroscience, or just computational modeling. So the great thing about neuroscience is it spans this incredible breadth of fields and techniques. And the great thing about music is that it includes this huge range of topics and experiences and behaviors. So there's a lot you can do with it. My students have gone on to academic positions like mine, geek out over some nerdy question and follow your nose. But I've also had lots of students go on into data science positions, clinical positions. They're very interested in using music to help or evaluating scientifically the outcomes of music therapy type questions. So we have a range of things that the skills that you get. Communication is another huge one. So learning to write clearly about complex things. Turns out that's something that's important across policy fields, across any sort of government position, across museum or any public outreach or charity organization, grant writing, professional writing. So there's a huge range of things that people can go on to do with these degrees, even if the specific topic feels a little niche, music and neuroscience. The nice thing about it is, even though it's niche, almost everyone can relate to the types of things that you're doing. Everyone has some experience with music, and some intuition about music. So yeah, I am happy at the end to take more questions on this field or what one needs to get into it, or yeah, anything else you guys have.
Thank you. That was wonderful, and a really wonderful introduction. All of our presenters, I gave them a really tough challenge. Like, take an entire field as well as your entire career and give it to us all in 10 minutes. But you just did it, so that's a great model. Thank you. We go from neuroscience and music to neuroscience and design, neuro architecture, neurodesign, and we'll hear next from Dr. Margaret Tarampi. She is the director of University Interdisciplinary Studies and an associate professor in the Department of Psychology at the University of Hartford. Her SCAPE laboratory, that stands for Spatial, Cognition, and Physical Environments, investigates the cognitive mechanisms that underlie space perception and spatial cognition, especially in populations like visually impaired individuals and spatial experts, such as dancers and architects. And other research interests include spatial thinking, perception, action, crowd dynamics, joint action, and kinesthetic imagery. Just reading that, Dr. Tarampi, makes me excited to hear from you. I'm sure everyone else feels the same way. So let me turn the floor over to you. Thank you for being here.
Thank you so much. I was excited to hear about neuromusic because there's so many overlaps with neuroarchitecture as well, for the same reasons in terms of the sensory experience, as well as the ideas of plasticity. All of these things are also paralleled in neuroarchitecture. But I just wanted to give a little bit of a background as to how neuroarchitecture developed as a field. And I'm just going to quickly share some slides because I think we need some visuals for neuroarchitecture. The origin story of neuroarchitecture started with Jonas Salk and a story that he told architects in the 90s about how he was trying to develop the polio vaccine. And when he was working tirelessly in his basement lab in Pittsburgh, he just came to a point where he was just mentally stuck. And he took a sabbatical to the monastery in Assisi, Italy. And he said that, let me just take a quote here because I think it's really poignant. The spirituality of the architecture there was so inspiring that I was able to do intuitive thinking far beyond any I had done in the past. Under the influence of that historic place, I intuitively designed the research that I felt would result in a vaccine for polio. I returned to my laboratory in Pittsburgh to validate my concepts and found that they were correct. What an amazing story to tell. And he then put forth to architects that you should study this. You should study the idea that architecture or the built environment can have such a profound effect on people. We spend the majority of our time in physical environments, both built and natural, and that they must be doing something to us. And in terms of architecture, there is a design process that's rather linear. I mean, it's quite iterative as well, but in terms of the research within the architecture field, a lot of it has happened on the tail end in how something is built, right? So things centered around construction, structures, acoustics, lighting. So we have a huge wealth of knowledge and development, and that has led to the great innovations we have seen in the field of architecture. And what the hope is in terms of neuroscience is that it will help us inform that beginning part of the design process. What is being built, right? So this part here about how do we design spaces that will inspire, do the things that Jonas Salk had described in his experience with the monastery at Assisi. And that really has set the tone for this field, which has really looked at different ways, both, certainly at the molecular level up through the systems and social neuroscience levels of how does architecture as a variable of its own impact the way that our brain is functioning. I think this quote is often thrown around by Winston Churchill: we shape our buildings and afterwards our buildings shape us. And I think in terms of what he was trying to convey was something that was really about the social aspect of our built environment. The idea that the way that we might think about social constructs like political relationships might then later on dictate then things like having a two parliamentary system. And he's arguing that it's the built environment itself that has influenced that train of thinking that we should have these two bodies instead of one that is like, if we had a different shaped building, he argued maybe that would have changed the way we think about space. And so that is, I think, the other part that we're starting to think more about in neuroarchitecture is just the idea of how we can think more broadly about the impact of the built environment. And so some of the things that we research has been looking at what is the effect of the size or the vastness or the aesthetics of particular spaces and how that has impact on things related to our memory and related to our ability to navigate, to be able to find ourselves, our ability to be able to think. And if you maybe recall in your own experience about being in different places, you could probably think of different buildings you've been in where you were like, oh, this is terrible. Or other buildings where you're like, this is amazing. And I love to work here. And maybe that has things associated with light. And so those are the kinds of things a lot of work has been focused on, certainly in the health realm. So health and well-being, looking at a lot of brain imaging work and also biosensors. So having people experiencing the environment. So just with technology developing year by year, we're able to ask different questions, like new questions, which is just really exciting. Just even the past 20 years that I've been involved in this field, there's been so much more that's been opened up to us. So my background is in architecture. And then I went on to my PhD in cognitive neuroscience. I think there's many different ways to approach this field, and depending on what you want to be doing ultimately. And I see that some folks want to be more on the applied side, so actually trying to influence what is being built. And so they might end up in a space where they become a licensed architect. And then I see other folks who are interested, like maybe myself, who want to do the research and ask the questions. And so then on that side, maybe you go on to pursue your PhD or some sort of advanced degree so that you have the capabilities to do that type of research. There's a lot more fields I think jobs available now within neuroarchitecture, in architecture firms, which is a huge development, is that architecture firms are now hiring people to do this type of research in-house. And we also see that there's a lot more labs internationally, particularly, where they're doing this different type of work. Certainly also extensions of many neuroscience labs who are now incorporating thinking about physical environments.
Great, thank you so much. That again, another tour de force, and we appreciate it. And I'm sure there are going to be some questions that follow up as well. But in the interest of keeping us moving, we're going to keep moving on. We'll hold our questions till the end, but a reminder, you can pop your questions in the Q&A. If we can answer them typing as we go, we will. I'm also putting in the chat lots of additional resources. So we transition, we've heard about neuromusic and the intersection of neuroscience and architecture and design. And we move now into two related fields, neuroeconomics and neuromarketing. And we'll hear first from Dr. Reed Montague. Dr. Montague is a neuroscientist at Virginia Tech whose research focuses on computational neuroscience, particularly the connection between physical mechanisms present in real neural tissue and the computational functions that these mechanisms embody. He has done a tremendous amount of work. We met when he was a key member of the MacArthur Foundation Research Network on Neuroscience and Law. And I don't know if you'll talk about it or not, but I'm going to just plug that Dr. Montague's early research involving scanning brains while people drank Coke and Pepsi in part spurred the entire field of neuromarketing. So it's really a pleasure to have you, and it speaks to the youth of all these fields. I think Dr. Rampe, you said about 2 decades, 20 years. One of the really interesting things, like all these fields are like a few decades old, right? They also all seem to have, I didn't know, such a connection to the Salk Institute, which I know you also have a connection to. But anyway, great to have you here. Thanks so much. And let me turn it over to you to talk to us about the intersection of economics and neuroscience.
Okay, well, thanks for having me, and thanks sort of for the plug on the Coke Pepsi experiment. That's like a bad habit that won't go away. I will mention it at the end. I love that, Margaret. That was fantastic, because I spent years at the Salk Institute, and I just remember I used to meet with Jonas on occasion. He would meet with some of the postdocs and staff scientists, and he was always an aspirational fellow. And the architecture of that place is I mean, it really is a great place. It's a special place. I'm a computational neuroscientist by inclination, and I'm a broadly applied neuroscientist in neuroeconomics, I guess neuromarketing. And in fact, I've even done imaging experiments relating people's responses on political ideology questionnaires to things that would predict what you would call something on a traditional conservative and liberal axis, amazingly predictive. These subjects are going to be accelerated in coming years as our ability to summarize our behavioral space with what's now called artificial intelligence is another interesting story, just so you'll know. The work that I started doing 27 years ago was in a laboratory at the Salk Institute, a computational neurobiology lab run by Terry Sinofsky, and I saw Pat Churchland whiz by at some point. She was part of the group. Francis Crick was part of the group, a guy called Chuck Stevens. And neural networks at the time were a backwater. They were a backwater. People that did artificial intelligence kind of made fun of neural networks because they would say, well, what can you do? You train this network and it can represent a 9-pixel bar, and that's about it. They can't really do much. I, in particular, worked on neural networks that were driven by what's called reinforcement learning. Same thing for reinforcement. Can't learn anything. The problem with that is it was true. And I can remember the day that Terry Sinofsky, this is pertinent for the young people, who's most of the people here except for me. One day at tea, somebody asked Terry about jobs we could get. He burst out laughing and said, I haven't promised anybody jobs. There's no jobs in this area. You guys are going to have to generate these jobs. But as Francis says, these fields have flourished. I mean, what Margaret just said about architecture firms. I had a postdoc who wanted to do neuroarchitecture with me. I kind of pushed him in another direction because I just didn't see, there was nowhere for him to go. This was about 15 years ago. No longer true at all. So neuroeconomics got born, as it were, in the late 1990s, early 2000s by literally just an admixture of economists that were interested in human behavior, neuroscientists that wanted to expand into a practical domain, and economics is, how do you value the world around you, acts, institutions, and exchanges, and how do you make decisions predicated on those values? Well, that's something that the brain has done ever since organisms evolved to be efficient. And so it was a natural marriage of the two things. It has had an impact, in particular, using exchange games and social exchange games in my world. So you design games based on essentially auction theory. And these games then can be used to go dig out brain responses about how you model the other person across the exchange. Those methodologies have now grown into something called computational psychiatry. They used to be just a word. Now then it was a kind of strung together discipline, and now it's a funding initiative at the National Institute of Mental Health. On the neuromarketing end, I'll end on this. I have 3 minutes left. There was a student in my lab almost 20 years ago today, 2003, who was my daughter. She was 16 or 17 years old at the time. She wanted a project to do. She was very interested in what happens when people have subjective preferences that are very different than one another, but the substance causing it is basically the same. And she started with candy bars. She was going to compare Three Musketeers to, I can't remember what, Mars bar. I can't remember what else. And we had a hard time figuring out as a project how to squirt candy bars through tubes. And so we landed on sodas, and we recapitulated what was at the time known as the Coke Pepsi taste test. They're basically brown fizzy sugar water. We squirted into people. Basically, we arranged a situation where you either knew what was coming, you didn't know what was coming. It was a huge difference, but not based on the contents of the fluid, but based on the expectations of the person. It fit it right into a kind of explanation of reward systems in the brain. And it caught both the good attention and bad attention of all sorts of people, including Ralph Nader, who called me up and wanted to debate me. Ralph Nader of Unsafe at Any Speed fame. He had an anti-commercialism group. You're disenfranchising people using medical instruments for this. And I said, no, we're showing things that people might exploit. Maybe Uma could weigh in on that at some point. So I saw it as completely legitimate. We're awash in type 2 diabetes. Sugared soda is one of the major culprits. And so I just saw it as a very practical application. Anyway, what started as a bunch of niche neural networky modeling folks explained a bunch of neural systems behaviors that had to do with reward learning. The reward learning then branches into becoming part of, not all, but part of neuroeconomics, neuromarketing, and even realms of neuroaesthetics. And you heard two versions of it today, which, would be, if I were a freshman, it would sound quite exciting to me. So that's the neuroeconomics short story. And it's interesting that we began with the picture of the Salk Institute, which is kind of where that started.
And I do see Pat Churchland, Arnon, for everyone's way for me to plug the website again. We were doing interviews with a number of these leaders I've had in the field, and I think yours is either posted or being posted soon, and you'll get more Salk Institute, and also how some of the genesis of these entire fields start from lunchtime conversations between engaging people. Thanks so much, Dr. Montague. We will finish our last presentation. We move from kind of still in the realm of economics as along with marketing, handing over to Dr. Uma Karmakar. She combines methods from consumer psychology and behavioral economics and neuroimaging to develop theory-driven frameworks about how people make decisions, all the way from those little neuron cells to actually what they're doing out there in the real world. She's an associate professor at the School of Global Policy and Strategy at UCSD, and also at the Rady School of Management at UC San Diego. She teaches marketplace behavior as well as marketing. And prior to this, was on our coast as a assistant professor in marketing at Harvard Business School. Thanks so much for being here. And let me hand it over to you, Dr. Karmakar.
Thank you so much. All right, I have to start off being a little defensive because not only did Reid take some of the good stories, then he's like implying I'm manipulating people here. If I was, I would have gone first. So...
Order effects.
All right, Reid, let's do this. A pleasure to be here, and thank you all for joining. Since I'm a marketing professor, I should probably start with a little bit of a discussion of brand names here. So the term neuromarketing was actually coined by my colleague, Alice Smits, who's at the Erasmus Business School, around 2002. And currently the academic field in particular, has mixed feelings about it. It goes great with the NeuroX theme here, so that's perfect. But because of some of the early work in industry, under the name neuromarketing, a lot of scholars have been uncomfortable with whether that term is tainted because it might imply manipulation or nefarious intent or even just bad science. So a lot of people choose to use the term consumer neuroscience. Some, the pushback, of course, is that whether your field starts gracefully or starts in fits, continuity is important and helps people understand what's going on. And so using the term neuromarketing helps with that continuity. So both pieces are there. But if you're someone who's interested in the field and you don't find enough of what you want under the title neuromarketing, you could look at the rebrand of consumer neuroscience and possibly find more. Fundamentally, I feel reasonably comfortable speaking for my 30+ colleagues who integrate neuroscience with marketing or other fields in business schools in saying that we're basically applied neuroeconomists. So we don't all do reinforcement learning or computational models like Reid does, but most of us tend to do research that would in some forms be relatively indistinguishable from some that's done by a person who is a neuroeconomist in a psych department. As I mentioned, there are over 30 business school faculty in this space now at schools ranging from public to private. So you can train in neuroscience or in a neuroeconomics lab and move into this space, or you can join a business school in their PhD program and train with one of us to also go into this direction or into this space. And that's a reasonably new thing. It took a while for business schools to hire neuroscientists. I think I'm maybe in the first 5 or 10 that wasn't hired. I think the first person that we was hired as a neuroscientist is my colleague Hilke Plasmet at NSEAD, and she only went on the market a couple years, or she only got her position a couple years before I did. So in terms of this sort of formalized space in academia, maybe we again claim that relatively recently, probably around 2009 or so. My impression of the neuromarketing job field in industry is that you can work for neuromarketing firms without a PhD, but to really have the most impact, partially because of those shaky starts, you really would benefit from having advanced training in the degree to learn some of the marketing as well as to learn some of the neuroscience, and to understand how to combine those things. And that brings up another point that I wanted to make sure people understood, because I don't think it's super obvious. Academic marketing is not the same thing as industry marketing. And so I'm in a weird way covering 2, maybe 3 fields. I'm a neuroeconomist, I'm a consumer neuroscientist in the academic field. I'm actually not a neuromarketing practitioner in that I haven't run these studies, nor do I have a consultancy or something. So I'm not doing this with firms for firm outcomes, because those practices and standards and expectations are somewhat different from the research that we do in the business school or in the universities. My day-to-day probably looks more like a version of a psych professor or a neuro professor than it does a marketing executive in one of those firms. And I'm happy to return to that for questions later on. So how do you get to this place? Like I said, we have multiple programs out there. I think one of the challenges in this field that you'll also probably find in the field of anyone who spoke is that you really are integrating multiple forms of expertise. And so marketing in particular has a massive academic history that people may not be aware of. We study decision-making in real-world noisy contexts. So the work that I do does have to live up to the best practices in neuroscience and an awareness and an understanding of how these things take place in the real world and whether or not they can be applied in real world context directly without having to wave my hands too much. We study a lot of questions that use these methods but have different target goals. So some of my colleagues study things like branding and pricing. Sometimes we study decision-making more broadly. I'm interested in how people integrate information in the world to make decisions. Now, my original background is that I was trained as a cellular electrophysiologist with a little computational modeling in a wet neuroscience lab. So I've been interested in how we use information throughout my career. I just used to do it with, recordings and models, and now I also do it with humans and grocery stores. I'll get back to that in a second. So one half of my research looks at situations where we don't have all the information we want or need to make choices. What does that mean in the real world? It's like picking stocks or making financial decisions or deciding how we're going to invest money or estimating your risk of COVID depending on event 1 or event 2, or deciding how risky a particular medical treatment might be. All of these are situations where we don't exactly know what the outcomes are going to be, and we have some information, but not maybe all the information we need. The other half of my work, and the work of many of my colleagues again, relates to situations where we actually have more information than we need. And as a consumer neuroscientist, one of the scariest things that I encounter in my day-to-day life is indeed a grocery store. Because everything in a grocery store is screaming at your brain. Where things are, the colors, the sights, the sounds, the smells, how things relate to each other, how they don't, the pricing, the messaging, the social implications of what you're supposed to be doing. All of that is relevant information for some decisions, but not for others. And all of it has the potential to affect what you might do next. That's terrifying. It's amazing that we all don't keel over from an aneurysm every time we run out for a box of cereal and walk into one of these horrifying high stimulus places. And yet, if you ask people how stressful it is to go get groceries, most of them will shrug. That makes it a cool problem. And again, myself, not only myself, but various of my colleagues look at different aspects of that problem to figure out how we are managing all of that and making it through our days comfortably. I suspect the Q&A is probably the most important part of this, so I'll let it go at that. But there are, again, significant resources out there, and I'm happy to connect with anyone who's interested in this field afterwards.
Wonderful. Thanks so much. And nice to see the synergy really across all four fields in many ways. And I had somehow, we couldn't figure out how to do it, but I was trying to think of a way that we could grab all of the fields we're going to cover over the next 4 days, throw everyone into a room and see what connections emerge, because I think there are a lot. But you're right that the most important thing is the Q&A. We're right on time. We have 15 minutes. So here's how Q&A will work for all those who are watching. There are 2 ways to ask your question. Some of you have already started way number 1, which is to ask your question via the Q&A option. Option 2 is to raise your Zoom hand. And then if we have time, I will call on you and I'll click a button and you can unmute and, show your video and ask your question live to one or more of our panelists. Let's start with one of these questions, which comes from Sami Jawar, and this is for neurodesign, neuroarchitecture. The question is, do you think there are therapeutic applications of neuroarchitecturally designed spaces, or is it more about improving general well-being by having more humanely designed spaces? And that seems to factor, I think, into career options in the sense that how is industry and how are designers going to use the tools that you're developing? In terms to Margaret.
Sure. Yes, absolutely. I think there's both therapeutic ideas in terms of in the healthcare space, how can we use the environment to speed up healing, essentially. Really early work that had started in the 80s that has really been built upon is work looking at just the relationship with nature, kind of biophilic design, some work by Roger Ulrich related to what can you see outside of your hospital room, where I think more so we're thinking about, can we now measure in more finite ways or physical ways the impact of the environments that we put people in, particularly in healthcare settings. I don't know what the other part of that question was, but
I think that's great. That's good. I will go next to neuromusic. I'm going to combine a couple of questions, Dr. Grahn. There's just sort of a general question about what are the hottest topics, but then one topic that somebody else raised is about research happening and understanding underlying brain mechanisms that aid in the therapeutic effects of music, kind of similar to the previous question on now music instead of architecture. And could this be a model to understand resiliency in brains? I'd like to add on that this extra one, which is sort of, okay, tell us about some topics. How can one get involved? And in particular, what would you recommend to probably many of our students on this call? There's nobody on their entire campus who does what you do. Where can they go? What would you recommend they start reading or checking out on YouTube, or what would be their next step? So what should they be looking at? What are hot topics? And then how might they get involved?
Yeah, absolutely. So applied aspects of musical interventions is a hot topic. NIH has had a few calls over the last 3 or 4 years that have been targeted at exactly this. How can we evaluate some of the potential neuroscientifically based interventions? So the key areas are rhythm and gait. So for Parkinson's patients and potentially some other gait disorders, steady musical or rhythmic stimuli seem to help with freezing of gait or problems they have with initiating gait. What are the brain mechanisms of that? No one knows. We have a lot of speculation, but this is a very active area of research that I am into. Rhythm and language and across development, can we use rhythmic interventions to enhance language aspects for all kinds of, for neurotypical children or those with developmental disorders as well? Music and emotion, probably the strongest evidence that consistent across many domains for the effects of music are on its mood regulation and emotional regulation. So there's a tremendous amount there from, for example, regulating anger or anxiety in Alzheimer's when people don't understand their surroundings and all of their things that they remember have been taken away. How can we get them through their day? But reducing confusion, and music is one way to do that, but also in other mood regulation disorders. So this is an active area of interest, and understanding the brain mechanisms. What's the role of the reward system? What's the role of enhancing your self-identity and affirming it? There are many ways in which music can work because it operates at these sort of basic sensory motor as well as cultural and personal levels. To get into this, I've always been the weird fish out of water person. I did my PhD where nobody did music. I did my postdoc where nobody did music. I had my faculty position where nobody did any of this. You find the people that you can talk to. Conferences are a lifesaver. So if you find yourself able to attend a conference, that will really be a fantastic way to see what the field has to offer. The Society for Music Perception and Cognition has a great website of all the labs in North America that do this. There might be more than you think out there, not too far, and they're often summer research opportunities. But any research that you experience will likely be relevant down the road to your specific interest in music. There are some books on the neuroscience of music. One that's a nice series is there's a conference called Neuromusic. It's been held every year since 2001. And they put out proceedings in the annals of the New York Academy of Sciences of what was presented. So that's a really nice overview as well. So yeah, I think it doesn't have to be music specific. You can bring the music angle to a lab you do psychological research in. And that's often the skills that you learn. They're very transferable.
I just thank you for that, and I just put the link into the society you mentioned. So I want to next, actually, maybe both Uma and Reed can weigh in on this. You mentioned skills, and several of our questions touch on something that we haven't touched on yet, but we really should, which is what skills do you need to work in these fields? And I'll just read each of the questions. So one asked Dr. Montague, what are the wet and dry skills one should have to succeed in the field? And similarly, in neuromarketing, most of the work done inside the laboratory with an MRI machine or by analyzing data. But if maybe both of you could sort of speak to the training aspect here, that would be really helpful.
Shall I go first?
Yeah, Reed, why don't you go first?
Okay. The main thing you need is an interest in what you're doing. I mean, there's no one in my lab, I can tell you, and they come from backgrounds in architecture, literature, mathematics, psychology, engineering. I'm naming people in the lab now. Linguistics. It goes on and on. Also, my labs are now spread out across the world and has been for 15 years. I have sites all over. In Denmark, I have a postdoc in Grenoble, one in Paris, Grenoble, France, Wake Forest, Phoenix, Arizona, Houston, Texas, and New York City. So the group has, since well before COVID just, we didn't skip a beat on that axis there, one. Two, all of those people have to come in and learn something new. Everybody comes in and learns something new. It never hurts to know more mathematics and statistics, but I have scientists in the lab that are fantastic scientists, fantastic thinkers about what they do, or deployers. of what we do. One of the methodologies that's now not quite turnkey, it uses atomic clocks to make direct measurements in the brain. It requires no cryogen, it requires no expensive liquid helium to run and whatnot. And it's motion tolerant, which magnetoencephalography and fMRI is not really. You have to have people sitting still. And there are already people from the place here studying mother-infant interactions and what could be called person-object interactions, the kind of thing Uma was sort of talking about with the advertising cacophony in a grocery store. So that is less and less an issue in laboratories like mine. We have so many people of so many different backgrounds. They sit in little groups and they basically teach each other. It's much better than it used to be 20 years ago. It's a kind of a vigorous environment in that sense. So there's always a way to pick up the skills that you need. I think focus on the questions, whether they be, how do I deploy this practically, or what kind of scientific questions I'm interested in. That's the motive force, that, in my opinion.
Thanks, Reed. Appreciate that. Uma, I'm going to add to your question just this one that came in, which is thinking about careers in neuromarketing. Are they generally independent neuromarketing firms or like little divisions within a larger company? And is there a lot of academia industry crossover? Or is it maybe more of a, one or the other? So maybe think about that too after thinking about skills.
That's a lot.
I know. Well, we have you for a very short period of time. And I think